Hi one and all, welcome back to the Digital Design Laboratory, and in this video we will discuss about experiment number 3, which will falls under part A. Part A means, have you remembered that part A experiments are hardware experiments, and the title of this experiment is we need to show one of the application of MUX, but we will not touch upon DMUX here. Okay, anyhow that you will learn in theory classes. Okay, here the objective is we need to show one of the important application of a circuit called multiplexer, right? Specifically, the objective of this experiment is, or this video is, we will learn how to design an interesting circuit called full subtractor using a multiplexer whose IC number is 74153, right? Okay, at a high level we shall understand what actually full subtractor means. Full subtractor basically is an electronic circuit, okay, and it will take three inputs. We shall label that inputs as X, Y and Z, and it will produces two outputs. We shall call one of the output as difference and borrow, right? So at a high level you can understand that full subtractor is basically a circuit which will take three inputs X, Y, Z, and it will produces two outputs. One is difference and the other one is borrow. So from this diagram, at a high level you can say that full subtractor job is to perform subtraction operation on 3 bits, right? 3 bits, right? Okay, and here what we have to do is we need to design this full subtractor circuit using a multiplexer whose IC number is 74153. Clear with the objective? Okay, once again I will repeat. What we have to do is we need to design this full subtractor circuit, okay, using IC number called 74153, which is actually a multiplexer. Clear? Okay, and finally what that full subtractor has to do, it has to do subtraction operation. Clear? We shall understand how actually it will perform subtraction operation with the truth table in few minutes. Clear with the objective? Okay, fine. Now we shall understand about multiplexer at a high level. Then after that we shall go to the truth table of the full subtractor, and we shall understand the operation of full subtractor, and then we shall see the pin configuration of 74153 IC, which is actually a multiplexer. Clear? Okay, now we shall understand about multiplexer. Multiplexer is basically a circuit. Okay, multiplexer is basically an electronic circuit which will have inputs. Usually inputs will be in the form of 2 to the power of n, and it will have n special input lines or control lines, okay, and it will have only one output line. Clear? So usually a multiplexer will be available in this form. Basically it's an electronic circuit which will take input in the form of 2 to the power of n. I mean specifically it will take 2 to the power of n number of inputs and n special inputs and only one output line. One simple example for this is, let us assume n value as 2. So how many number of input lines will be there if n value as 2? Then it will have 2 to the power of 2. 2 to the power of 2 means what? It will have 4 input line. Okay, we shall label the input, I mean these are 4 input lines. We shall label the input line as 0, 1, 2, 3. Clear? Okay, and how many number of special input lines will be there? How many number of special input lines will be there? 2, right? Because n value is 2. Right, and how many output lines will be there? Only one output line will be there. So we call this as a multiplexer. More specifically, this multiplexer is called as an 4:1 multiplexer. 4:1 multiplexer or MUX. Make it simple. Okay, what this 4 stands for? This 4 represent number of inputs and this 1 represent number of output. Okay, in case of 4:1 multiplexer, how many number of special input lines will be there? Okay, 2, correct? So this is how, or in this pattern, multiplexer will be available in the market. Like this we can have a 8:1 multiplexer also. In case of 8 is to 1 multiplexer, how many number of input lines will be there? Okay, 1, 2, etc. up to 8 input lines will be there. How many number of control lines or special input lines will be there? 3 in this case, because 2 to the power of 3 is 8. And how many number of output line will be there? Only 1. So this is how, this is also another example for multiplexer. And you can similarly you can have 16 is to 1 multiplexer, 32 is to 1 multiplexer, like this in the market. Clear about the multiplexer? Okay, now we shall go one level below and we shall understand what actually the job of this selection line is, and what is the job of this input line, what is the job of the output line. Clear? Okay, this is very important. Okay, as the name itself says, this we call as special input lines or control lines. Clear? Okay, actually what is the job of these control lines means, so actually based on the value of these control lines, it will choose the input line. Okay, it will choose the input line, and the signal coming or passing through that input line will be sent to the output line. Okay, I will give you an example for this. Okay, if okay, I will label these control lines as A and the second control line as B. If A value is 0, B value is 0, what this indicates, what is the decimal equivalent of 0 0? So 0, it means it will select. Okay, we shall call this as data line 0, D0, and this as D1, this as D2, for better understanding, that's it, D2 and D3. I mean, these are data lines or input lines. Okay, if the selection line value is 0 0, then it will select out of this 4 input line, it will select D0 as a input line, and at that time if you are supplying 1 through this line, then what would be the output? Output will be 1, right? Okay, similarly if the A value is 1, B value is 1, 1 1, what is the decimal equivalent of binary 1 1? It is 3, right? It means in this case it will select data line 3, right? And if you are passing at the time 0 0 0 in D3 line, then what would be the output value? It is 0. So now I hope with these two examples you understood what is the job of this control line. Actually, control line will control, or it will decide which out of 2 to the power of n input line will act like an input line. Clear with this? This is very important. Okay, we shall come back to this pin diagram, as I said, later in few minutes. Now we shall go to the truth table of full subtractor, and we shall understand the job of full subtractor. Okay, so as we discussed in few minutes back, full subtractor will take 3 inputs. Here the inputs has been labeled as A, B, C, and it will gives us 2 outputs. One is difference and the one is borrow, right? Clear. And how many number of entries will be there in this truth table? Obviously it is 2 to the power of 3. Why it is 2 to the power of 3? Because the circuit is taking 3 number of inputs. So totally how many number of rows will be there in the truth table? 8. Clear? 0, sorry, or I can count from 1 itself. 1 2 3 4 5 6 7 8, like this. Correct? Okay, fine. Now we shall see how what is the job of full subtractor. As I said, at a high level, what actually full subtractor will do, it will perform subtraction operation on 3 bits, right? Okay, now we shall go one by one. First it will take 0 minus 0. What is the difference value? 0. I am writing intermediate result here. Again 0 minus 0 is what? Difference will be 0 and borrow will also be 0. Clear? Okay, again 0 minus 0, difference is 0, borrow, we don't need borrow here, correct? Okay, again 0 minus 1. Interesting, I can't subtract 1 from 0, right? As a result, we need to take borrow here. So that's why borrow bit has to be set to 1. Did you understand why borrow bit has to be set here? Because I can't subtract 1 from 0, hence we need to take borrow. Since we are taking borrow here, we need to set the borrow bit. And when we took the borrow, this 0 will become 1 0. Clear? This 0 will become 1 0. And what 1 0 means? what 10 in decimal, it is actually 2. 10 means decimal equivalent of this 10 means it is actually 2. 2 minus 1, 2 minus 1 is 1. That is the difference. Clear? Okay, I hope you understood how to come up with the values for difference and borrow. Okay, if you don't understand at this point, I will continue with the same explanation for further inputs. Okay, now 0 minus 1, again interesting, I can't able to subtract 1 from 0, right? As a result, what we have to do, we need to take a borrow. Since we need a borrow, we will set this bit, and when we took the borrow, it will become 10. 10 is in binary. What is the decimal equivalent of 10? It is 2. 2 minus 1, we can do the subtraction, right? 2 minus 1 is what? 1. Okay, then now we need to subtract 1 minus 0. What is 1 minus 0? It is 1, right? Correct, no? So like this, okay, no problem, I can continue up to the end. Okay, 0 minus 1, again I can't able to do subtraction, we need to take borrow. Since we need borrow, we will set this bit. Okay, when we took the borrow, it will become 10. Decimal equivalent of this 10 is 2. 2 minus 1 is 1. 1 minus, sorry, don't treat this as an minus. 1 minus 1 is 0. I hope you are understanding, right? Okay, now 1 minus 0 is what? 1 minus 0 is 1. 1 minus 0 is what? 1. Whether we took borrow here? No. Hence it will be 0. 1 minus 0 is what? 1. 1 minus 1 is what? 0. We don't need borrow in this case, so it will be 0. 1 minus 1 is what? 0. Right? 1 minus 1 is 0. 0 minus 0 is what? 0. Whether we need borrow in this case or we took borrow in this case? No. That's why it will be 0. Right? 1 minus 1 is what? 0. Interesting. 0 minus 1 is what? I can't able to subtract, right? So hence we need to set the borrow bit. When we took the borrow, it will become 10. Decimal equivalent of this 10 is 2. 2 minus 1 is 1. So this is very, very important. If you go wrong here, then the future steps or the further analysis or further design will go wrong. Clear with this? This is very, very important. I hope you understood how to come up with a truth table for a full subtractor, and with the help of this full subtractor, parallelly you understood the job of full subtractor circuit, right? Clear? Okay. Now we shall go back to the pin diagram of the IC called, whose IC number is 74153. Actually, basically it is an MUX. It is an MUX. MUX means multiplexer. Clear? Okay. Now at an high level, have a look at this pin structure of multiplexer. Totally 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Means totally it is of 16 pin IC. And just observe carefully, there is one pair called I3A, I2A, I1A, I0A, A something, and YA. Can you see here? YA. And similarly, can you see something called I3B, I2B, I1B, I0B, and YB? Right? Okay, see here, this is one MUX labeled as A, and this is another MUX labeled as B. And how many input the A multiplexer has? 1, 2, 3, 4. And I hope you can tell me now what is this YA means. YA is actually an output line of the multiplexer A. So I can say A is 4:1 multiplexer here. Similarly, what is B? What is YB? It is an output of this multiplexer labeled as B. So similarly, even here it is 4:1 MUX, right? So at a high level, we can understand that an IC 74153 will have 2 4:1 multiplexer, right? 2. And which are those two? We have labeled the first multiplexer as A and the second multiplexer as B, right? And what are this? What is this S1 and S2? They are nothing but control lines or selection lines. How many selection lines will be there in 4:1 multiplexer? 2, right? 2, right? Correct. So that's why this S0 and S1 are selection line. And what are these EA bar and EB bar? So E stands for enable pin. This is an enable pin for the multiplexer A, and this is the enable pin for multiplexer B. And what is the job of this enable pin? As I said in the previous class video, so this enable pin will enable the IC to work. Means only if you supply proper value to this enable pin, then only the multiplexer will work. I mean, you will get the result. Otherwise, you won't get the result. But so in the market, you can have a multiplexer. Okay, you can have a multiplexer with enable pin or without enable pin. Clear? But here in the laboratory, we are using a multiplexer with enable pin, right? Okay. What would be there in case of a multiplexer without enable pin? Means it will not have an additional pin called E there over there. Clear? Okay. But anyhow, you will understand major difference between enabled and not enabled in theory classes. Clear with this? And the common connections, I hope you can go through by yourself now. Okay, this pin number 8 is a ground connection, or we need to supply ground to this pin number 8, and we need to supply voltage at pin number 16. Clear? Okay, this is about the pin diagram of IC whose IC number is 74153. Clear? Okay, now once we understood this, okay, now we shall go to the major design. Now what we have to do means now, as I said, we need to use this multiplexer, right, to design a full subtractor, right? And full subtractor will have how many outputs? One is difference and the one is borrow, right? Okay, now what is the plan is or idea is, we will use one multiplexer to focus on difference and another multiplexer to difference on borrow. Okay, so that's why here we have used okay, 2 4:1 multiplexer. Okay, what is the first multiplexer here? Has been labeled as A, and the second multiplexer has been labeled as B. We shall use A multiplexer for difference or to handle difference, and B multiplexer for to handle borrow. But there is no rule that you should use A only for difference, B only for borrow. Okay, but we are following left to right fashion or a pattern. Okay, clear with this? So once you understood this, now we shall go to the major design concept. Okay, we shall go one by one. Okay, first we shall focus on difference, then we shall focus on borrow, right? Okay, so what you have to do means, since we decided multiplexer A should be used for difference, and what are this I0A, I1A, I2A, I3A, these are nothing but the input lines for multiplexer A. Clear? Okay, now below this I0A, I1A, I2A, I3A, generally input line, just write a continuous number like this starting from 0, 1, 2, 3, 4, 5, 6, 7. So what actually these numbers are the index of the truth table, or the index row of the truth table. 1, 2, 3, 4, 5, 6, and finally, okay, for better clarity, okay, I will keep like this so that I can get a full view, complete view. Okay, so as I said, we are focusing on multiplexer A here, and these are input lines of the multiplexer A. And what I said, just write a continuous number starting from 0, 1, 2, 3, 4, 5, 6, 7 like this. Why it should start from 0? Because look at the truth table. So truth table, usually the decimal equivalent of this binary will be 0, 1, 2, 3, 4, 5, 6, 7. I hope you understood what are these. These are nothing but decimal equivalent of the binaries. 0, 0, 0 in decimal equivalent is 0. 0, 0, 1 decimal equivalent is 1. 0, 1, 0 decimal equivalent is 2. 0, 1, 1 3. 1, 0, 0 4. 1015, 1106, 1117. So these are nothing but the row index. Clear? Row index of this truth table. Clear? Okay. Now you have an option. Either you can find the inputs for this multiplexer A by focusing on the first input, or you can focus on the second input, or you can focus on the last input. So it's your choice. It's your choice. But here we will focus on A, or we shall try to design, or we shall try to find the input for the multiplexer by focusing on the input line called A. Clear? Clear. Okay, fine. Now let us begin with this. Let us try to find the value of I0A line. I mean I0A input line, which is one of the input line of the multiplexer A. Okay, what this indicates? So this indicates row 0 in the truth table, right? So it means focus on row 0. Focus on row 0 and focus only on difference column. Focus on row 0 and focus on difference column. And you need to focus on row whose index is 4. This one whose index is 4. Okay, focus on this. Okay, fine. I hope you are understanding. So just choose row 0 and row 4 and see what is the difference value when A value is 0 or A value is 1, right? Okay, now what is the value of difference here? Is 0 when A value is 0. And what is the value of difference here? 1 when A value is 1. Now what you can conclude from these two? Okay, in terms of A. Okay, what would be the D value in terms of A? See, once again I will repeat. D value is 0 when A value is 0. D value is 0 when A value is 0, right? Okay, and here D value is 1, right? D value is 1. At that time, what is the A value? 1 when A has the value 1. So what we can conclude? D is equal to A, right? Correct, no? D is equal to A. So hence we concluded that the value for I0A will be A itself. Clear? Okay, exactly in the same way we have to do for other cases. Okay, I will explain one more case over here. Okay, I1A. Okay, now we shall try to find a value for another input for the multiplexer A. Okay, now what this indicates? Look at row number 1, look at row number 5. Look at row number 1. This is row number 1 and focus only on the difference value. And look at row number 5. This is row number 5. Okay, what is the value of difference here? 1 when A is 0. And what is the value of difference here? 0 when A value is 1. Okay, what we can conclude? Okay, once again I will write here, when difference is 1 when A value is 0, and here difference is 0 when A value is 1. Means if A becomes 0, difference is 1. If A is 1, difference is 0. So finally I can conclude the value is nothing but A complement, right? So that's why A bar or A complement. So similarly you need to find out the value of I2A, I3A. So exactly what you have to do now for I2A, you need to look at row number 2, okay, and you need to look at row number 6. Okay, and do the same exercise what we did like this and find out the value for I2A, similarly I3A, and you after finding the input values for multiplexer A, you need to find out the input values for multiplexer B, right? The difference here it is the same, even here it is same. You need to start running numbers starting from 0, 1, 2, 3, 4, 5, 6, 7 like this, and you need to figure it out the values for I0B, I1B, I2B and I3B. How will you do this? Again, same thing, same procedure that you have to apply, but instead of focusing on instead of focusing on the difference column, you need to focus on borrow column. You need to focus on borrow column now. Borrow column now. Okay, once again I will give one example, one demonstration. Okay, now we shall try to find out the value of I naught b itself. What we have to do, we need to look at row number 0 and row number 4, right? Okay, we should focus on row number 0 and row number 4. Row number 4. So here what we have to do, we need to look at borrow value. This is what I said, you need to focus on borrow column instead of focusing on difference column. You see, what is the value of borrow when a value is 0? Borrow value has 0 when a value is 0. And what is the value of borrow when a value is 1? When a value is 1, borrow value is 0, right? When a value is 1, borrow value is 0. Means, what is the conclusion that you can give it here? So whether you change a to 0 to 1 or 1 to 0, no matter, the value will be 0 itself, which is a constant. The value will be 0 itself, and hence the input value for I naught b will be 0. Clear? Similarly, like this, you need to find out the input value for I1b, I2b, I3b exactly by following the same procedure. Clear? Okay, this is the design. This is very, very important. Once you find the input values for difference and borrow, then you can come up with a final circuit diagram which will act like an full subtractor. Okay, actually this is a full subtractor which has been designed using multiplexer whose IC number is 74153. Clear? So I will explain now that circuit diagram. Okay, we shall have a look at this circuit diagram. Okay, so this is our multiplexer, and can you see, this is a multiplexer as well as this B multiplexer. These two input value for B and these two A. Okay, enable pins, ground pin. What are these two? These are nothing but selection lines. Okay, where we are supplying other inputs like B and C, and this is our one of the very important input signal called A, because we have designed this full subtractor based on this input signal only. That's why it is A here. And okay, this is the voltage supply, and since we are using multiplexer A for difference, here you will get difference as a result, and multiplexer B for borrow, here you can expect borrow value. Clear? Okay, now I will explain how we did this. Okay, how we did that connection. Okay, for better clarity I need to zoom it out. Okay, I think now we can able to see both the difference and borrow. I need both this. Okay, fine. Now shall see here, what is the value of I naught A that we found? It's basically A, right? So can you see here, we are supplying A directly to I naught A, and for I1A, what we need to supply? Complement of A, right? Can you see, this is an NOT gate, so A we are passing to this NOT gate, and complement of that we are passing to I1A. Can you see here, I1A? And similarly for I2A, we need to supply the complement. That's why, see here, I2A complement, and for I1B complement, I2B also complement, right? And for I3B, one we need to supply. For I3B, where it is I3B? Can you see here, I3B, say VCC, we have connected to VCC. VCC means, remember, 1. Ground means 0. And for I naught B, what we need to supply? 0. I naught B, where it is I naught B? Can you see here, I naught B we have connected to ground. So like this, we need to do the connection. Okay, and we need to write the pin numbers for individual input and output lines. For this input and output lines, how we can able to write this? Okay, what you need to write that? Okay, what you need to write that? Pin diagram. One example I can quote here is, what is the value of pin number for YA 7, for YB 9? Okay, YA 7, YB 9. Okay, so can you see YA here? YA pin number is 7, YB pin number is 9, and voltage it is 16. So like this you need to fill this diagram with the pin numbers, and that diagram will become the final logic diagram which act like a full subtractor. Okay, which will take three inputs. See here, A one input here, B second input, C another input, and produces two outputs like difference and borrow. And you need to use this diagram, and you need to verify the truth table of full subtractor. So if you do this, this experiment will be get completed. Clear? Okay, so I will conclude this video. So just what we learned in this video is, we learned how we can able to design full subtractor using a multiplexer. More specifically, we have used a multiplexer whose IC number is 74153. Clear? Okay, in the coming videos you will see how we can able to connect, or we can able to do this connection, okay, in the trainer kit on using the patch cords and ICs, and how we can able to verify the respective truth table. Clear? Okay, once again, if you have any doubt, you can either WhatsApp me or you can contact me. Okay, with this I will conclude this session. So thank you one and all.